All right, let's get underway. Welcome everyone to NDC Sydney, well, at least to the start of the tracks for NDC Sydney. I hope everyone got to catch the keynote just before. This is what we've kind of aptly named the AI track, because when we were doing the agenda, there was more than enough AI content that we could have run the entire event on just like AI-centric talks, but that wouldn't have been kind of a great representation of where the tech industry is at. So we've got like this whole track. So it's my pleasure to be kicking us off with this talk about generative AI for .NET developers. My name is Powell. I work for Microsoft in the cloud advocacy team. I'm a .NET developer at heart. I've been doing .NET for about 20 years now, but it's always been web applications. And when my boss asked me to take over the AI strategy for our team, I was pretty skeptical on it. Like I'm not an AI researcher. I'm not a data scientist or anything like that. I'm a consumer of REST endpoints is kind of the way that I think about how I engage with AI. But I was skeptical. It's like I didn't jump on any of the other tech fads that have come out in the last couple of years. Blockchain, quantum, NFTs, and stuff like that. I'm like, I suppose I had to pick one of them though, right? So, well, I ended up with AI. If you want to reach out to me after the session, if I don't answer any of the questions that you've got or anything like that, find all contact details and everything up there on the screen. But that's enough about me. We're here to learn about AI. And naturally, the first thing people say is like, oh, you're doing an AI talk. Did the AI write that for you? Well, I mean, that's for you to determine when we go through the slides. See how many of them you think that I wrote versus how many was just generated by a variety of co-pilots that we have here at Microsoft. But like, obviously, it's a fairly standard joke, is AI going to take our jobs and all that kind of stuff? And I'm not going to try and answer that question for you today. Hopefully, I'll give you some information where you can work out what role generative AI in particular can play in the sorts of applications that you might be building. But rather than go through a whole bunch of slides to start up, I want to do a demo of a kind of application that we could be building. So this is an application written entirely in .NET, and then we're going to break down the parts that come together to make up said application. So let's head over to, I have a .NET Aspire application running. So if anyone isn't familiar with .NET Aspire, go check out the sessions from Damien and David Fowler throughout today. They've got 2 or 3 sessions. I can't remember how many we told them they're doing, but they'll be covering off a whole bunch about Aspire. This application is using a Postgres database using PG Vector extension on it to store a bunch of data around that supplement for the application. I have an Azure storage account, and then I have a background worker process, which is a console application. I have a web application, which is our front end, and I have a back end web server. All of it to build a chatbot. But this chatbot in particular it's trying to help me solve a problem. Like, I'm time poor, and there's a podcaster out there that has close to 1,000 episodes in his back catalog. So the Hansel Winners podcast, there's almost 1,000 episodes in there, right? Which ones do I want to listen to for the sorts of things that I'm interested in? So I can ask a question, say, I want to learn about retro gaming and emulators. And we'll hit find episodes, and like there's a whole bunch of live demos, so I'm just going to kind of fingers crossed that none of this breaks, because there's a good chance that it will. And no, there we go. That worked. Excellent. Okay, so I want to learn a bit about this stuff. So what it's done is it's given me an answer to that question. So some information about retro gaming and emulators. Actually, no, like, there's no point in me reading this.
Retro gaming and emulators have gained significant attention in recent years, with enthusiasts and developers working to preserve and recreate classic gaming experiences. Emulator.
Okay, thanks AI, Aaron. You can all read the rest of that large chunk of text. It would probably take a while if I was to leave that there. But then if I scroll down a bit, you'll see that it's recommending a bunch of episodes for me to listen to learn more about this. So the one from just last Thursday with Jose Tejada on retro FPGA gaming. And then, because I asked about game emulation, we've got one from 2023, January last year. And we can see that it's identified. Here's the speaker that was being interviewed by Scott in the episode. Here's some topics that are key to that. So I've got there, and we can see the relevance of that to the question that I asked. So the reason that it gave me this first one with Jose is because that was 83% relevancy to the question that I asked it. I've also got a 1-line summary of what that episode is. A 2-line summary of that episode that is kind of just summarizing the description down and of what that podcast is all about. Now, what's interesting about this is that if we come to the Hansel Minute website, well, we can see that the speaker is listed in the title, they're listed in the abstract, but they're not actually like, they're not called out separately. There's no specific like link here to that speaker. If they were a repeat speaker, maybe you could find other episodes with them, but that's not there. If we look in the raw XML that comes back from the podcast feed, again, like here's that episode. Where is it? It's this one here. Again, this information is embedded inside of like the description and the title. It's not tags. There's no topic information. There's no retro gaming topics or anything like that. Instead, I've used generative AI to extract all that information out of this so that I can enrich the application experience, meaning that I could come back here and say, I want to just find retro gaming as a topic and then refresh that search up here that I've got so that I could narrow down the filters inside of it based off of particular topics, subtopic of a question that I'm interested in. So that's the kind of application we can build with generative AI. But let's talk about how we can get there. Because that application is entirely written in .NET, but we'll get there, and let's build up the pieces along the way. But because this is an introductory talk, I want to start with a bit of intro on how generative AI works, because understanding some of those fundamentals is really key to knowing how we can use them in applications that we're building. So when we talk about large language models, or LLMs, these are the kinds of models that underpin generative AI. These are models that have been trained on all kinds of textual data, whether that's books, websites, articles that have been written, social media posts, although I question whether social media posts are a valuable thing to train models on. We've seen what happens when you do that with other models on like just Twitter. That's not great. But basically anything that's text consumed by these models to then build out their their neural network, their internal algorithms to then give you the ability to engage with them. Now, what makes an LLM or these kinds of LLMs different to the sorts of things that we've had in the past is they're multimodal. Instead of having a model that can do object recognition, which is just trained about how to recognize people inside of a static image, and then you have a second one which is doing categorization of text, and another one that's doing sentiment analysis, and so on and so forth. All of that is extracted from a single. That single model can be done capable of doing all of that, so this is actually running kind of like one model behind the scene to do all this sort of stuff. But the way that these models work is that they're going to try and predict something for you. So let's start with that prompt that I've got there on screen, once upon a time. We give that across to our LLM, like GPT-3.5, GPT-4 from OpenAI, and we get back a response of, in a quaint village nestled between rolling hills in a marine, and so on and so forth. That seems like a fairly logical continuation of that sentence that we started with. If we think about nursery rhymes, folk tales, and stuff like that, trained on English data, it seems like a logical continuation. Because it's using a probability distribution to determine the next sequence of tokens to return back to the end user. So how does that work from kind of an application flow? Well, we start with a natural language prompt that comes in. We turn that into a series of tokens, which is then turned into a series of numbers. This is given to our large language model, which then does a probability distribution algorithm to work out what is the next logical token to give you back. That token is then appended to the prompt that was given to it, which is then turned into natural language and sent back as output. Simple, right? Well, here's a much more simplistic view of that. We start with n number of tokens in, and we get one token out. Now, I keep saying the word token like you know what I mean, right? I can see some like nods of like, yeah, I assume that's something I should have known. Oh, no. The point is to explain all of this stuff. That's why it's a bit of an introductory talk. So you might be mistaken in thinking that a token is a word. A token isn't a word. It's not a single character. And it can be a word, it can be a character, or it can be part of a word. Let's take this phrase up on screen at the moment. We need to stop anthropomorphizing ChatGPT. You would not believe the number of times I have had to practice saying the word anthropomorphizing to get it right on stage. That's a lot. And this was actually written by someone that doesn't speak English as their first language. So I was like, why did you choose that word? The reason is because this is broken, there we go, I got it wrong once. It gets broken down into three tokens. Words like we, need, to, and stop, they're single token words, because they're common words inside the English language. It's also worth noting that the white space character that precedes, particularly need, to, and stop, is part of that token, because the white space is significant in the way that it would generate a completion. Anthropomorphizing, on the other hand, is an uncommon word in English language. So it's broken down into 3 tokens. Also, because parts of this word can be used to build up other words. So those sub-tokens can be used, or those tokens, sorry, can be used to build up other words. Take the suffix izing, written by an American. That is a suffix that can be used on multiple different words. So it would make sense that we store that as a token in and of itself. So how it works is through an expanding window pattern. So we start providing it with our context, so the thing that is preceding the tokens that we're looking to get back. We need to, and then it could predict that the next one is stop. And then from stop, it might predict anthrop, and so on and so forth to complete out that sentence. Now, the LLM itself is going to try and do one token. It will do one token at a time. Now, that doesn't mean that you have to always get back one token, and that's like, it's a lot of streaming requests that you're going to be doing to the model. No, the model will keep running until it hits some kind of a stop condition, maximum number of tokens returned, or some other stop condition you might have defined. But it's going to internally just be doing one token and then building on that newly appended token to produce out a full statement. So you might be wondering if this is deterministic. Well, the shorter answer is no. The longer answer is no. Which actually makes for really fun demos using generative AI, because you never quite know what you're going to get, because it's non-deterministic in the result set. But there are ways that we can make it more deterministic. It wouldn't be a great tool to add to applications if it's just like, what are we going to get back in a response today? Who knows? We want to control that in some way. And we can control that with 2 values that work on a scale of 0 to 1. Those are temperature and p-top, or top P, depending on which SDK you're using. .NET, we call it top P. Python, it's p-top, I think. And Java and JavaScript, they kind of have a mix of that. And then those are the only languages I kind of look at. These are used to control things like randomness and creativity within inside of the model. So temperature in particular is controlling the randomness and creativity only within and of itself. So let's say that you push it towards 1. So push it towards like 0, so like 0.1. That is going to be a highly deterministic response that you're going to get from your LLM, because, and it kind of, I look at the responses that it get that comes back, and they're almost clinical in the way that it gives you an answer. It's an answer, it's factual, it's all those sorts of things, but it's very direct wording. It doesn't have auxiliary words around it, things that you would more expect in kind of a humanized response. Push that 0.7 or something like that, and you're going to get more of a conversational sort of response back, the thing that you would expect when you're talking to another human being, as that's more what you would be looking at as you make your temperature closer to 1. P-top, on the other hand, is used to control the amount of tokens that are available in the models, in the predictive, the prediction algorithm that the model has. So push it to, say, 0.1, and we're going to get the top 10% of possible tokens to be returned, so potentially a very narrow set of tokens. Push that closer to, say, 0.5, you get a much larger range of tokens, resulting in more randomness, more creativity in the styles of responses that you can get back. So this is just an example where we don't have the exact implementation of the algorithm. OpenAI hasn't shared that information with us, but this is kind of like how we can think about it in at least in a slide deck. So now let's talk about prompt engineering. Anyone who's spent any time on job boards over the past 12 months is like, oh yeah, look, they're looking for 20 years of prompt engineering. Great, I'll put that with my 30 years of React experience. Like, is prompt engineering just like the new buzzword of recruiting? To a degree, yes, but there is also a skill involved in creating useful prompts within inside of applications to give you the kind of outcomes you're looking for. So let's take the 3 different styles of prompting. We can have an instruction, something that we want our model to do. Translate this code from Python to C#. And we're giving it a direct instruction. We're probably giving it that code that we're wanting to translate, and then we'll get that as a response back. So the model it understands what we're wanting it to do, so it can give us that outcome at the end. We can ask it for a completion. So we start off a statement, and then it's going to complete off that sentence, that paragraph, whatever the case may be. And that's the example of once upon a time. That's kind of we're running a completion there. Lastly, we could ask an open-ended question. What is machine learning? Or what is artificial intelligence? And that can come back with an answer based off of the data that the model itself was trained on, and up until its knowledge cutoff date. So this is where it starts being capable of producing answers that are quote unquote out of thin air, and things that helpful for you to try and figure out a question and a decision that you want to make as a result of that. Now, when you're working with prompts and some umbrella things with prompt engineering is treat it as someone who doesn't understand anything about your company. They're a new hire or an untrained intern or someone like that. So avoid biases or avoid assumptions inside of the prompts that you're giving it. Translate this code from Python. Well, I know my code base is C#. Why doesn't the model? Why is it giving me a JavaScript response? Well, because I have an assumption in there that it just assumed that it knew that I was working with C#. No, I've got to be explicit about that. Otherwise, it doesn't know what to do. Avoid having too big a problem that you're wanting it to try and solve. The bigger the problem, the more decisions that it can potentially make and the more potential directions the result can go in to give you a varying answer and potentially a less useful answer for your users because they don't know where it's going to go. And provide additional details where possible. The more information you can give the model to ground what it's doing and ground its knowledge so that you can keep it in place, well, then it's going to give you an answer that's based off potentially more accurate things rather than things that are just made up. When it comes to making prompts, there are two main prompts that we work with. We have the system prompt and the user prompt. The system prompt is what we use to create the personality of the assistant that we're going to be working with. In this case, I've created an assistant prompt where it says, you're an AI assistant that helps people find information and responds in rhyme. If the user asks a question you don't know the answer to, say so. So then a user comes in with a user prompt that says, what can you tell about me, John Doe? And then our assistant would come back with a response such as, dear John, I'm sorry to say, but I don't have info on you today. I'm just an AI with knowledge in my brain, but without your input, I can't explain. So please tell me more about what you seek, and I'll do my best to give you answers unique. So we can see that that's done two things. It's in a rhyme, clearly, we've got a whole bunch of rhyming words there, but it's also said that it doesn't know how to answer the question that you've given it. And those are things that we've told our assistant as part of the system message, part of its quote unquote personality. That's what it's doing. It is going to be grounded in that information, and that's and it will kind of respect that as the box that we're trying to put it with inside of. All right, so when we're using text, like text is the most common thing that we're going to, at least that I find us doing with large language models. Here's a couple of really common scenarios that we tackle. Things like content generation. Now, I want to generate a social media post, a LinkedIn article, or something like that. Generate content based off of a slide deck that I'm working on. So we're going to generate that as net new. I use that kind of when I'm writing a blog post in VS Code. I've got GitHub Copilot running, and I'll start writing a sentence for it, and it will predict the completion for that sentence, and then I'll just massage that to be in my tone of voice, or use that as a way to kind of get over writer's block. Speaking of GitHub Copilot, code generation is obviously another really good use case for text. That's just text at the end of the day. It's just text that is being contextualized around the programming language you're working with, the other code that's in that file, and other files that might be open with inside of your editor. Summarization, we've just, I think it's only just been made publicly available, but Microsoft M365 Copilot, it's like, I've got a button in my emails where I can click summarize this email. It's great. I don't have to read my emails anymore, just summarize. Like, summarize the transcript from a meeting that I didn't watch or I didn't attend to determine whether I need to watch it and stuff like that. So summarization is a really good use case. And that was some of the early stuff that they were doing in GPT models of proving that it could do things that with data that it wasn't previously trained on. Searching semantically against information to give you more contextually relevant result sets, and obviously chatbots. No doubt most people in here have used ChatGPT or are at least familiar with ChatGPT. That's a really good use case for generative AIs. So some prompt engineering tips before we jump into a demo with text. Use the system message to craft the tone and style of the assistant that you're working with, so that you set the expectations based on what you want your users to have, and that the assistant is going to try and respect those as best as it can. And where possible, provide history. We call this chain of thought prompting, where we provide past prompts that the user has given us and the assistant messages that have come back, so that we can have that continued conversation. We don't have to, as a user, I don't have to restate my question over and over again, because it understands that history that's in there. Provide examples and ground the prompt that's come in from the user to make it more contextually aware with inside of the request that you're sending to your LLM. We call this meta grounding, so we add some more information around that. Lastly, put guardrails in. You don't want to be the next company that appears in tech media of like, someone's figured out how to pop your assistant on your website, and now they've just basically got ChatGPT, but it's on your dime instead of them paying a subscription to OpenAI. There's countless articles that you can go out there and find about this. There was one a couple of weeks ago about an auto manufacturer that people had figured out how to pop it, and it's like, your car cost is only going to be $1, and that's legally binding. You don't want to be that company, right? All right, let's just do it. Have a look at the basics of text generation with .NET. So I'm going to fire up a new instance of Visual Studio, and we're going to create a new project. Create just a console application here. Let's load in my project templates. I have like half a dozen Docker containers running at the same time, so everything's running a little bit slow today, but that's for the other demo. All right, there we go. .NET 8 console application here. The first thing I'm going to need is the .NET SDK for working with OpenAI. So let's install that. The one I'm going to be using is the one that we've released from Microsoft, the azure.ai.openai. There are a couple other ones out there that the community has produced. Evaluate the one that's going to be right for yourself. I use this one because it's the one that I'm most familiar with, and it just kind of does the stuff that I sort of need it to do. I got to go into the right folder, and then we'll install the package. It is I think it's pre-release at the moment. Preview 13, I think, is the current version. All right, so we're going to grab. So I'm going to need some information. I'm going to use Azure OpenAI as my backend rather than direct OpenAI. But this SDK could go straight to OpenAI. You don't have to be using Azure resources for that. I just have obviously access to Azure OpenAI. So we're going to create an endpoint, which will be a new URI. And we're going environment.get environment variable, OI endpoint. And then we'll just do a throw new exception if that isn't set. And then we're going to create a key. Sweet. We'll just pull that out as AOA key. We're going to create a OpenAI client, and that we'll call client, and we'll do new OpenAI client. We'll give it the endpoint and an new Azure key credential with that key. All right. Like I said, if you wanted to just use OpenAI directly, you just use a different overload on that in the constructor. So we'll create a prompt. I'm just going to create this as a static prompt within inside the application. What are the top 3 features of the most recent .NET release? All right, and then we will get back some results, which will be from client.streaming. I'm going to use the streaming response. Oops, whoa. Oh man, where is my, there we go. Like, I have things in the, too small a screen real estate. Okay, so we need to provide with a model definition. Again, this is something you need to do with Azure OpenAI Service, because we can name our models specifically. If you're using OpenAI, it's just going to be like GPT 3.5 Turbo, GPT 4, et cetera, et cetera. For convenience sake, I call this GPT 3.5 Turbo, and I need to provide it with some options. So I'm going to create some chat completion options. Options equals new. This is where I provide the model. So this should be GPT 3.5 Turbo. And then I provide it with an array or a enumerable of messages. So this is our history. I'm going to do a new chat request user message. We give it that prompt. Thanks, Copilot. And then we'll come back down here. I don't need to provide GPT 3.5 Turbo there. I give it the options. Okay. What is it? It's F11. F11 is run. I don't want run. I wanted full screen. Let's Alt-Enter. Close that. Boom. Okay, things are breaking, but that's all good. Okay, so now we will just do a wait for each through the result set, because this is a streaming response. So it's going to give us back tokens kind of as fast as the model can generate them. You can also do just a normal chat response where it will give you the full completion once the model has finished all of its token generation and hit whatever stop condition you want. But I want to do streaming because that's kind of that experience that you see in like ChatGPT where it's like, words are appearing and so on and so forth. So I'll just do var result. That should be results. Results. And results. There we go. Spelling is hard. Live coding is fun. Okay, if not string dot is null or empty on the results dot content update. So we get an update back as part of a streaming response. So if there was some update, so if there was an update that came back, we are then just going to console dot, we'll just do write, and then we'll do result dot content update, so that it continue, like it's a continuation, because write line we'd end up every token on a new line. Okay, let's hit F5 on that and run the application. Zoom this in a touch. All right. Well, okay, so that's what it got back. It actually ran a little bit fast, just to kind of show streaming. I'm just going to do it at a wait task delay. We'll not do 1,000. We'll just do like 100 milliseconds. Let's run that again. All right. Okay, so there we go. So it's talking about performance improvements, C#9 and F#5. And so you can see how we're getting tokens, or at least partial words coming back in the response. But C#9 is kind of like, that's not the most recent C# release. Neither is F#5. Like, that's not the most recent one. So this is where we've got a bit of a problem in our knowledge of our model. It's because I'm using a GPT-3.5 Turbo model. This is trained up until September 2021. So it understands to .NET 5, .NET 6 previews. I think we're out at that point in time when training cutoff happened, which is why we have some outdated information. So instead, let's improve the knowledge of our model by grounding this prompt a little bit. I'm going to come up here and I'm going to add a new message in here, which I copied earlier, just making sure it was still in my clipboard. Chat request system message. So in our system message, I'm going to say multi-line string. This goes back over here, comma there, and then I'm going to put in some more information. You're an assistant that helps people learn about .NET. The most recent version of .NET is .NET 8, which was released in November 2023, and then some information about the features of that. Now, if we hit F5 in this, let's see what we get back as a response here. Okay, so the top 3 features of .NET, so it now knows .NET 8, so it's referring to .NET 8. Performance enhancements, because that's what I said was a feature. Cloud native applications, things like Aspire, and I'm not sure what it's going to pick as the third one. AI integration, yeah. There we go. Because those are information, I gave it a set of things that were in there. But see how we can add some knowledge to our model. I haven't retrained that model. I've just added some knowledge into that prompting so that we get more of an accurate response back. And that is how we can, that's the starting of prompt engineering, is doing that kind of stuff. So it's all good to talk about text, but well, computers don't use text internally. Computers use numbers, and models themselves are just big things of numbers. I mean, they're more complex than that, but they're just, I didn't say they're a big database of numbers. No one, oh wait, I did. No, that's recorded. They're more than just a database. Models are not just databases. Don't use them as a database. But we can actually work, like working with numbers is something that we will commonly do with our LLM systems. Then we do that through a feature called embeddings. Embeddings are a numerical representation of the text that we've provided, the concepts within inside of that text, the individual words, and the relationship between those words and the concepts. The ADA model series from OpenAI, so ADA 2 is the most recent one. ADA 3 is in preview. They announced it like 2 or 3 weeks ago, I think it was. They generate an array of float values. I think they're 64-bit float values. And these are then, they're a vector representation. There are 1,536 vectors within inside of this, which means that we can model the relationship of this a bit of text to other bits of text in multi-dimensional space 1,500 times. I don't actually know how to conceptualize that inside of my brain, but that's what we can do. And the reason that we would do that is by having a numerical representation of like the words and the concepts and stuff like that, we can then do semantic analysis of that to other like relevant ones using some kind of a similarity algorithm. Cosine similarity seems to be the one that's most popular at the moment, and that just basically like, I've got a big array of numbers and I've got an equally large array of numbers. How similar are they to each other? That's how we got the 0.83, et cetera, similarity response with inside of our demo earlier. These arrays of numbers we then would store in a vector database, something like Postgres with PG Vector, Azure AI Search, Quadrant, so on and so forth, so that we can then perform semantic searching against them. Let's just very quickly have a look at what that looks like inside of a database. So here is the Postgres database. No, that's the console application. Here is the Postgres database that's running the Hansel Minute Bot web application. We'll see the ID of all the documents that I've indexed, or all the podcast episodes. And then we have this embeddings column. Just to click over onto that. And then there is a absolute truckload of float values. But they're all the same length. It's all 1536, or is it 1532? I'm not sure. I should check my notes. It's over 1500. But they're all the exact same length, which means that we can do similarity operations against them. We can use like cosine similarity. And then like internally, the database will do, it will index that column so that we can then just query against that in a similarity search manner. And then the way that we would use this in our application is that we would take that prompt that comes in. I want to learn about retro gaming and emulators. We would generate a vector of that and then pass that in and say, what ones have I previously stored that are similar? So generating the initial set of vectors actually takes quite a while. This one takes the better part of a day to generate across the 1,000 episodes. But the result set of that is that you end up with quite a large data set that you can then look at in the future. Let's talk about custom logic, because that's something that we might want to have to our application to make decision trees based off of the way the LLM works, because having a natural language prompt is so much more convenient for users. I can ask questions in the way that I want to ask questions. I don't have to try and figure out what are the keywords I have to put into a prompt to trigger the right bit of searching. With OpenAI, we have a feature called function calling. Well, it used to be called functions. It's kind of still called functions, but they're deprecating that name and they're calling it tools now. So it's functions and tools. They're fundamentally the same thing. What we do with this is we generate a JSON structure that we provide as part of the prompt that goes up with the user prompt to then look for information inside of that user prompt to then get a JSON response back. So in this case, I've created one called search hotels. I'm saying that it's going to have some properties inside of the user prompt I'm looking for, a location and a max price. And then when we have the user prompt comes in, hotel with private beach, max cost 300 euros in Delmaris. Instead of giving me a text completion of a hotel you might be looking for in Delmaris is blah, 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 it comes back with a JSON payload. Location Delmaris, max price 300, because those are the things I said to look for with inside of that prompt. Now, it's worth noting that while these are called functions or have traditionally been called functions, that's not executing something inside of your application. It's not executing a function. It's giving you information that you can use to execute a function. And this is why I'm glad that they're renaming it to tools instead of functions, because it was a little bit confusing. You're not exposing your application's internal logic to the LLM. You're getting information back from the LLM to then do something with inside of your application based off of that result set. Let's have a look at a demo of functions. And this time, I'm not going to type out the code because it's a little bit more complex. Instead, I'm going to jump over to LinkPad to one that I wrote earlier. So here we go. I'm creating the connection to OpenAI using the OpenAI SDK as before. And what I'm then doing is I'm creating a chat completion function tool definition. That's a mouthful. In this, because, well, it's .NET, we have to, we use a .NET object structure rather than just like loose JSON. But here we go. We've got the name of it, get podcast info. The description is it extracts information from the podcast description. And the things that I want it to extract are going to be the summary. And then I tell it some information about how I want that summary constructed. Go away over IntelliSense. So generate a summary from the podcast description provided, summarized to a single sentence. I want the topics. I want a comma separated list. It was still actually generating a comma separated list, even though I said a common separated list from of topics from the description, and a comma separated list from the description excludes Scott Hanselman, because while he's a speaker, he's a known speaker across all of the episodes. What I do is I'm creating the chat completion options. I'm giving it 2 user messages, which is the description of 2 different podcast episodes. And then I call the chat completion async instead of the streaming, because I want that JSON payload to come back as a single JSON lump. I don't want, there's no point streaming this response. And then we have a look through this. We look Is the finish reason, the reason that we got that completion back, is that because of the tool call? If it was, we're going to have a look at our, we're going to extract the tool calls out of that, and we're then going to deserialize those and just dump them out in LinkPad. So let's run this one. And we'll zoom in the bottom here once we get our response back. Zoom, 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 and we'll see here, we get a tool response. We have a summary. Quincy Larson, the teacher who founded Free Code Camp, yada, yada, yada. Topics, Quincy Larson, Free Code Camp, Learn to Code resources. The speaker was Quincy. And then using the one with Jose. Interestingly, it didn't respect what I said of don't include Scott Hanselman. It still included Scott Hanselman in that. So, and this is where you kind of have to work on, well, is there something I should change about the way that prompt works? Should I have added a system prompt that also instructed it to exclude Scott Hanselman? And this is where, like, from a prompt engineering standpoint, you iterate on the prompts that you're working with to get back the responses you're getting. But yeah, you can kind of see what you got from there. That's how we extracted those topics. And that's how then on the web application I had speakers, I had topics, and so on and so forth. In my own application that actually runs that demo, it does a few things to like sanitize the data a little bit more, like removes things like Hanselman and Scott Hanselman as topics because, well, they're not really topics. And then this comes to speech. Speech is something that, well, we've been doing speech for a long time. Speech in, this is not a new thing. Speech to text, doing live translation, live transcriptions, that's been around for quite a while. The difference with the LLM-based ones, so with OpenAI, that's the Whisper model family, the speed that they can respond with.
The ocelot, Lepardus pardalis, is a small wild cat native to the southwestern United States, Mexico, and Central and South America. This medium-sized cat is characterized by solid black spots and streaks on its coat.
And the accuracy. Like, there's some complex words in that. Things like Lepardus pardalis. That's a complex word. Who's been to a talk where they've had live transcription that's machine generated and someone has said the word sequel? That's a fun one to see translated. But with these LLM-based live transcriptions, like, it's so much more accurate in that. Like, it understands complex words and technology terms and things like that. But the other thing that we can do with this is we can do live translation. I can go from English spoken to, say, Italian as an output. And then that brings us to the next idea, which is speech to text, text to speech. Again, not exactly a new thing because I've got Google Homes in my house and Amazon Alexas and stuff like that. Like, that's doing text to speech. Again, that's not new. But it's the fidelity of the language that comes back. So let's take this sentence. To best meet your needs, I would recommend the following. Or?
To best meet your needs, I would recommend the following.
Thanks, AI, Aaron. So for this one, I've actually trained it using a custom neural voice. So rather than just a machine-generated voice, this has been trained on my voice. I provided, for that sample there, I provided with 34 utterances. So those were about 6-word phrases. I just read them to my computer and it would tell me whether I mispronounced stuff or whatever the case may be. And then it spent about an hour training. And it got me that level of almost accuracy. I would say it's probably about 75% my own voice. It doesn't have tones and inflections and things like that I would normally have when speaking. There are definitely some Americanisms in there. I played around with it and they had the word ask, and it was very ask, not ask. And don't get it to say my name. I'm not Aaron. I'm Aaron. But that was on like 34 phrases, right? The next step up from that is the Pro model which we've got inside Azure AI Service. That one takes a minimum of 300 phrases, and that generates much higher quality audio. But also then we can go into the next aspect of that, which is fine-tuning of the audio model. Using the speech synthesis markup language, SSML, say that fast 5 times, that we can use to change things like the pitch and the tone of the voice talent that we're working with in the applications that we're building. So let's have a look at how we use speech from a .NET perspective. I'm going to come back over to LinkPad, and I have my speech demo here. So this is using a different SDK. It's using the speech SDK, not the OpenAI SDK, because just how it works. So what I've got here is I'm loading up the endpoint key and everything like that. I'm glad I've sanitized my keys because I can see people taking photos of it. It's also recorded. I'm using a neural voice, that I've generated. This is actually using the Pro neural voice, not the light one, which was what I had in the slide deck there. So we create the speech config, we define the audio quality that we want, what's its output going to be. I generate a location on disk that I'm going to then write that to. I then give it a prompt that I want it to say, and let's just kick that off because it'll take a little bit of time to generate that. And then it's going to generate output, generate a WAV file output. So I'm just generating this as WAV file outputs using a speech synthesizer, and we're waiting till we get a completed response back. So let's copy this path. So this is path of the file that's generated, and we'll paste that in.
Hello, NDC Sydney. This is AI Aaron speaking to you, and I hope that you are looking forward to this event. I wish I could attend in person, but as I am not a person, that would not really be possible.
Thanks, AI Aaron. I've been doing a lot of heavy lifting today. But we can see that from like 10 lines of code, and I can take any bit of text up to there's a character limit. You can't put like War and Peace in there and get it to read you War and Peace. Well, you could. You would just have to chunk it down to a lot of really small files. But like 10 lines of code, and we've added an accessibility layer to our application using a voice talent, such as myself, to represent the personality of our assistant, the brand that we're working for, or whatever the case may be. All right, let's talk about the knowledge of the models. Let's say this prompt here, is Queen Elizabeth II still alive? And the answer to that is going to vary depending on what model you're working with, because the models have a knowledge cutoff date. We can see there things like GPT-3.5 Turbo, mentioned earlier as well. Cutoff date was September 2021. GPT-4, that was last year, it had its cutoff date. So a response to come back could be that she's still alive. Maybe not. I mean, let's not get into conspiracy theory world. Or it could come back with a response where it's like, look, based off of my training information, this is my answer, but I might be out of date. So the models are, they don't necessarily have all the answers because they don't know beyond a particular point in time. But they also don't know about your organization. Let's say I work for a fictional company called, I don't know, Contoso. Probably heard of them. And we are an online outdoor like clothing retailer. So we want to have a way that people can come and ask natural language questions like, I need warm waterproof shoes to go on a hike. Well, we pass that to our LLM and it's going to come back with, sure, I can help you. Here's a shoe that you can that would be fitting that. Well, but what if I don't have those? Like, they're not ones that we stock. We're not a retailer for that brand. Or like, I want to direct people to the purchase path. I want them to click through to the product page on my website to get that. Well, how do I do that? Well, this is where we add data to the prompt. So we put this in the meta prompt that goes up with the user. We saw that where we added some knowledge around .NET 8. So in this case, we might add some information. So like, here's a bunch of trail walking shoes that people might be interested in. And then the prompt comes in, asks for warm waterproof shoes to go on a hike. And it comes back with saying, sure, here's a product, the trail walk hiking shoes. Here's the ID. Here's the link to that with inside of our product catalog. So the person can then go across and purchase that. So that very natural flow into like a checkout process. And it's done through an experience where someone hasn't tried to figure out, like, I don't know what the shoe's called or anything like that. But what if they said, I need shoes to keep my feet dry while going on a hike? Well, like dry doesn't necessarily match anything with inside of our database. And is dry any words that we've got with inside of that text that we've got there? Probably not. This is where we might want to look into something like the Retrieval-augmented generation pattern, or RAG pattern for short. So in this case, we get the user prompt that comes in, and then we're going to perform some kind of a query over it. We might go out to our LLM and generate an embedding for that, and then do a semantic search against our previous, like our product list, which we've generated embeddings for and stored them in a vector database. We then select only the relevant ones based off of our relevancy threshold and return those back. That goes to our LLM to complete the prompt of the user's initial question, grounded on knowledge that we've figured out from their initial prompt, so that they're getting contextually relevant information. We're not trying to load our entire product database into a prompt, because we're probably going to run out of tokens to be able to send. We're only getting the stuff that's relevant to them. And ultimately, that's how the application that we have for the Handsome Minutes bot is working. So let's go back over, now that we've seen all these little pieces, text generation, embedding generation, so on and so forth, let's see all of that, how it comes together inside of the application. So we start with our text prompt. I want to learn about retro gaming and emulators. For this, I've added a system prompt that's you're an assistant that helps people find information about a podcast from the Handsome Minute podcast. You're going to provide links to relevant podcasts that people will want to look for. We have our text-to-speech there, which is taking this large chunk of text, generating a WAV file, and then streaming this back to the browser when the user clicks play. And then we get back these semantically relevant results from our application. So the application itself is made up of, it's a .NET Aspire application. It's got a whole bunch of different stuff in here. So inside of, let's start with our app host, and we'll just have a look at all the things that we're popping in here. All right, Alt-Enter. Full screen, no. Control-Shift-P, full screen. What's the keyboard shortcut? Control-KZ, oh cool, I was gonna muscle memory that one. Okay. So to start this application up, we're going to look for a bunch of things like the get configuration information and whatnot, because I want those to be cascaded through to all of our sub-applications. This is an Aspire talk, but I just want to touch on some of the key parts that we've got in here. I've got an Azure storage account, which I'm using to store the status of our indexing of the podcast episodes, because I do this in the background using a worker process. So I pop a message on the queue, say index this podcast. It's then going to run that indexing process. And if I shut down the server, it can pick up from where it was previously at stepwise. Because this is running locally, I'm just setting up the emulator with some known ports. And I'm mounting the volume so that every time I restart the application, it doesn't start with no data. When taking better part of a day to generate your data, you don't want to be doing that multiple times in a day. Then create a queue and a blob storage resource. Then have a Postgres database where I'm specifying a custom container image here on line 43 for using PG Vector, because I want that extension. If I was deploying this to Azure, PG Vector is a native extension within inside of Azure. I've just got some debugging as well, so I can see all the SQL queries that happen. And I mount additional SQL script to scaffold up our database. I'm then creating a memory project. So this is the service that I call to ask that question of, which is then going to do the LLM generation and response. I have our loader project, which is the one that's going to load data into the index. And then I have a front end. Let's have a look at the worker. And because I am an F# fan, I'm contractually obliged to show F# at least once in a talk. So sorry, if you're only coming here for the C#, this is F#. Come talk to me more about F# if you want to. There are dozens of us that care. This is just a background job that's running. We'll see we have our OpenAI function. I wrote this a while ago before they changed from functions to tools. So this is using a slightly different syntax, but you can see there I'm asking for the summary, the topics, and the speakers as comma-separated lists. We then serialize that down. And then we come down and we call we get our chat completions here. I'm not doing this asynchronously, I was having some problems with the asynchronously. I have a branch that's better async, but yeah. We go out, we generate those responses using our GPT-3.5 model with our function definition or our tool definition. We then unpack that payload, extract the speakers, the summary, and the topic, and then send that over to our memory client to index. So it's then going to generate the vectors, store those in Postgres, and then make an endpoint available for searching, which happens in this chunk of code down here, for import memory record, which is up here. We have our memory client. Now for the memory application, I actually didn't write much of that code. I'm using an open source project from Microsoft called Kernel Memory, which is kind of like RAG pattern as a service. It's a library you drop in, or in this case, I'm running it as a web server in program.fs. Let's find the right one. Here we go. So I'm just creating a kernel memory builder here, attaching the Postgres database, the blob storage, saying that I'm going to be using OpenAI text embeddings and OpenAI text completions, or text generation, they call it. And then this is using queues as orchestrators for all of that. So it's a lot more asynchronous background processing and so on and so forth. But I haven't had to write any code to actually touch an LLM in this case. Not to generate embeddings, not to write into PG vector, not to handle the request that comes in from the user to then find the semantically relevant options or anything like that. I have an upload endpoint where I send it the podcast episode description and tags and the speaker and all that kind of stuff. And then it will import that document. This will also take care of things like chunking. Let's say you've got a PDF document. You can just upload the PDF. It will then extract all that text as small chunks, generate vectors of those chunks rather than of like the entire document, because you've got to find that balance between how small do you want those vectors to be to give you useful semantic results versus how complex do you want people to be able to put prompts in. So again, that's from a testing standpoint. You kind of got to iterate on, am I chunking, like am I chunking on paragraph? Am I chunking on page? Or am I chunking at some kind of gap in between? I've done this kind of a demo on YouTube video transcripts. So I could actually do this one, but use the podcast transcripts instead of the podcast descriptions. And in that kind of stuff, you want to chunk. We found the sweet spot was about 3 minutes. Let's say you got a whole bunch of internal training videos, pull the transcripts from those, chunk them down into 3-minute time segments and generate vectors of those, store them in a database, and then have an interface where someone can ask questions, find the point within inside of a training video for them to be launched directly into. If anyone wants to see, learn more about that kind of solution, I do have a sample application running that, like I said, on YouTube playlists. So YouTube videos and transcriptions. And yeah, we were deep linking to like the point in a YouTube video that was relevant to a question that someone wanted to know the answer to. I thought that was kind of cool. The other major endpoint here is ask a question. So this is where I put in that prompt. I want to learn about retro gaming and emulators. It's going to go into the memory. It's going to ask that question of my memory. The question, it's going to look at the index because I might have multiple indexes here. It could be the transcriptions, it could be the podcast episodes, or this could be for multiple podcasts. If that was the way that we designed it. Are there any filters? Are we looking for a particular speaker or a particular subtopic that's been extracted from that description? And what is the minimum relevancy here? So I'm using, I think, a 0.8 relevancy. So it's got to be 80% relevant to the prompt that the user provided us. And then this is going to generate me a response that I send back to the client. Which, if we come into home.razor.cs, we have a function here called doAsk. Naming things is hard, okay? We get our user prompt that's come in, just make sure that there was actually a user prompt provided. If there was, we're going to clear out previous answers, we're going to clear out previous sources, we're going to clear out, set the loading state to true, delete all previous audio files. We're going to look to see if they had any selected speakers and topics, add those as filters to our memory call. And then we're just going to memory, ask this question. Here's the filters, here's the minimum relevancy. And it's going to come back with the answer. So that was that large chunk of text that we had at the top here. Retro gaming and emulators, that's the answer to the question that someone was asking. And then what were the sources that made up that? So what episodes were relevant to produce that answer? Iterate over this. So in this case, each source represents a single podcast episode because they're pretty short descriptions. But you can imagine that if you were doing this on like a transcript of an episode or a full PDF, the source might be, the relevant source might be page 7 of that PDF, and that gives you that back. Instead of here is a 30-page PDF of like a product disclosure statement in PDF form. Your relevance, the relevant answer is in there somewhere, and you've got to then just like great, I could have just read the PDFs myself. But no, like being able to just like say, here is the relevant page, even like the relevant paragraph within inside of that page, just means that you can dive straight into it. And then lastly, once we get that back, we pass the answer across to our speech service. This is also why the link pad thing said answer instead of prompt, because I just copied the code across from here. The answer that comes back from our LLM, we're going to generate the WAV file and write that out to disk. And then I've just got some error handling that I didn't have within inside of LinkPad. But with that, and looking at the timing, I think we're pretty much done. And we do actually have some time for questions. But yes, at the very least, thank you for coming to this session. I hope you've learned more about the pieces that can come together to build a somewhat complex, or at least what seems like a somewhat complex application. And we saw that we start with just a text prompt that comes in, but we can ground that on our own data. We can ground that on contextually relevant data to the prompt that the user has provided us. We're not just going, here's a prompt, answer that question and kind of figure out, ChatGPT style. We're grounding it on our particular organization. In this case, our organization happens to be the Hansel Minutes podcast. We're giving you relevancy based off of that. And like I said, there's about 5 minutes left. If anyone's got questions, throw your hands up, and I can see a bunch popping up already. Excellent. Microphone, yeah.
Let's say I have a company website with specialized knowledge, which might be on a firewall or password protected website.
Yep.
Is it possible to train the LLM on that website?
So a good question. Like one thing I didn't talk about in adding knowledge to the model is whether or not you should be training that model. Generally speaking, no, you wouldn't actually retrain those models. So the models that we have from OpenAI, they're what we call foundational models. You kind of just leave them alone. They do the things that they do. What you then do is you add data to the prompt that you have extracted from the website, from a knowledge base, or whatever the case may be, as part of that prompt request that goes up. So the model itself has not been retrained, but you've grounded the question the person has asked on the knowledge of your organization, and then it can answer the question based off of it. There's a whole deeper set that you can go into prompt engineering around what you do with meta prompting, how you ground knowledge more deeply, how you avoid jailbreaks, how you instruct it and stuff like that, which I'm happy to take offline because it's a whole topic in and of itself. But no, generally speaking, you shouldn't be retraining these models, because that results in a lot more complexity down the track. New models come out, you've got to retrain again. And GPT-3, so the oldest of these models, that took 9 days to train in Azure. It cost $4.6 million US. So you don't want to be training models at any kind of frequency. You want to be working out how you can add information to them. You augment, which is what the RAG pattern is designed for.
Yep, okay, thanks.
Had a question up here. Just down the front. Just on that while the mic's coming out. So the library I use there, kernel memory, you can actually say, here's a web page, and it will extract the text out of that web page. You don't actually have had to do that text generation yourself. So yeah, it's a really cool project. I'd recommend checking it out as a evaluation tool in kind of projects you might be building. Yeah, sorry.
A quick question. Do you have the source code for the things that you show in GitHub somewhere? Or?
Yes, they're in GitHub. Are they public? No. No, so that Hansel Minutes app that I had there, I'm going to make that public. It's been in a private repo as I've been iterating on and some stuff like that. They also released Preview 3 of Aspire like 7 hours ago, and it broke all my demos last week when they released it. So I'm using like Aspire Preview 2, an old version, and that was another reason why I didn't make it public, because it was like, great, I don't want like this half-broken thing going out. So I'm going to do some polish on that, but it'll be on my GitHub, github.com/Aaron Powell. I think it's called Hansel Minutes Bot. I'm also going to try and talk to Scott, see if we can put that like actually on the Hansel Minutes website, because that is really cool. Like, it's a great way to discover stuff. Yes.
What's the major difference between OpenAI and Azure OpenAI?
The main difference between Azure OpenAI and OpenAI is probably the responsible AI stuff that we have inside of Microsoft. So we've got a lot of additional things that you can tune over the top of the GPT models to avoid things like generate potentially hateful responses or sexualized content and things like that. there are ways that you can obviously do that with the OpenAI ones. I know that OpenAI Enterprise also supports some of that stuff. We have a bunch of built-in features to do that you can tune and modify based off of the needs of the kinds of applications you're building. The other value proposition I see around Azure OpenAI service over the top of just generalized OpenAI is the integration into Azure. I can connect in Azure AI Search, for example, with just like the click of a button. And while that vector database that I had there was in PG Vector in a Postgres database, if I push that into Azure AI Search, I can connect that into Azure OpenAI service, and then I can do something like prompt flow to do a low-code approach to building out this kind of a prompting application. Obviously, we're .NET developers, so we write .NET, but we just have more seamless integration of things like a vector database, as an example, and the responsible AI stuff as well is another one. I think there are some more sessions that dive a bit more into Azure OpenAI service over the next 3 days.
I have a question about chat history management. So when you're getting relevant knowledge through the embeddings, usually it's about the latest question that's come in. But as the conversation continues, things may not be relevant. And then I feel like I'm wasting tokens and it blows out the cost.
Yep.
You can imagine a conversation can end up being $3 per query and it may not be relevant to previous. So is there like a solution that you feel like for chat history management?
Yeah, there's no one size is going to fit all kind of solution for history management. There's a couple of trains of thought. First off is like a FIFO model, just like the oldest ones you drop off as they lose relevancy. The other is giving a UI option for people to be able to delete messages out of history. So it's like, okay, that's no longer relevant, or that's like artificially influencing the prompt that I'm now trying to put in. The other one is looking at like having kind of that decision tree that's in there. Like if you see the responses come in and you look at that prompt using like a function call first and say, hey, this one is asking about, this one's asking about hiking shoes. Okay, so I'm going to add stuff with hiking shoes. And then we see follow-up questions which aren't triggering tool flows. And then we get another one that triggers off a tool flow. Maybe at that point we actually delete past history, or we discard it and then inform the user that we didn't include past history because we've deemed it no longer relevant. If you want that relevancy, explicitly opt it back in. I actually really like using functions or tools. Naming's hard. I really like using that to do decision trees with inside of it. But then also you start building out with, say, orchestrators like Semantic Kernel or LangChain, and they've got opinionated approaches to doing history management as well. I know we're at time. I'm happy to stay around and field questions, but also if you do want to leave, don't feel like I'm going to make it awkward for you. Well, I mean, I am, but I'm not going to make it more awkward for you. But at the very least, thank you for joining me today. I hope you've learned something new. I hope you're inspired by the way you can use AI. Enjoy the event.